Okay, so we're trying to find member CG. So we're looking at this middle guy right here, trying to find that one, okay? And again, when we're trying to find one, it's probably best just to do method of sections, but you'll see there's no way that I can cut through this and only cut through 3 members, right? If I make a cut here, that goes through 4 members. Some people might think, well, make the cut like this, okay? But what happens here is that's essentially a joint analysis at C. I don't get all the members go to the same point, so I don't have a moment equation. So I really only have 2 equations there. So what I'm going to have to do here is make a cut here and then figure out probably CD. Once I get CD, then I can go to that joint analysis at C to finish things out. Okay, so from this, I'm going to go ahead and draw my free body diagram, right? So I've got 260 right here. This is a 5, 12, 13 triangle. Then I've got FFG right here. I have, this looks like a 3, 4, 5 triangle as well right here. This is FDG, okay, where this is going to be 4, 3, 5, like so. And then I've got this force right here. That'll be FCD. And doing an inverse tangent of this triangle right here, I can find that this is 14 degrees. Okay, and I get that from the inverse tangent of 1/4, right? Because essentially I've got this triangle right here that I'm dealing with. Okay, where this side right here is 1, the other side is 4, so that's where that 14 comes from. So I have that. Okay, now again, what I'm interested in finding is FCD. So because I want to find FCD, I'm going to take a moment in such a way to get rid of these other forces. So I am actually going to take a moment about G, and again, G is not on the body, which is fine, but FFG and FDG both go through that point. Okay, so if I sum the moments about that point, the only unknown I'm going to have is the one that I'm interested in, which is FCD, which then I'm going to use to find the member that I'm actually looking for, CG. Okay, so I'm going to take the moments about G. Okay, I'll start with my known force. That's 8 feet away. That's creating a negative moment, and that's a horizontal distance. So I only care about the vertical component, which is going to be 12/13 times the 260. Okay, now again, the only other moment that I get here is FCD. Okay, and what I'm going to do here is I'm going to take this vertical distance right here, which is 4 feet up. Okay, and I only care about then the horizontal component of FCD. And again, I can do this because I can draw from the point to anywhere along the line of action of the force. So I'm going to go up to where CD is, okay, and just worry about that horizontal component with that vertical distance away. So again, that vertical distance, this is going to be a positive moment. That vertical distance is 4, and then it's FCD. And again, I just care about the horizontal component, which will be cosine 14, okay, and set that equal to 0, okay. Going through this, I find that FCD is 495. Positive answer tells me that it isn't, that my assumption is correct, that it's in tension. So I put that right there. So now I move to joint C, knowing member CD, and again, member CD is right here, and again, that's 495. In that direction, this is going to be 14 degrees again. I have FCG, this is what I'm looking for. And then I've got the other force over here, FBC. Now, symmetry tells me that's going to be the same answer. To prove that to you, we'll just sum the forces in the x direction, and I get 495 cosine 14 minus FBC cosine 14. Whoa. From that, I learned that FBC is the same as FCD, which I suspected due to symmetry. Okay. Now that I have that, I can go ahead and sum the forces in the y direction. okay, where I have my negative FCG here, and then I have minus 495 sine 14, and another minus 495 sine 14, those two members there, okay. From that, I learned that FCG equals negative 240. Negative sign tells me that my assumption of tension is incorrect, so I'm going to call that 240, and I'm going to put it in compression, and that is the answer that I'm looking for. Okay, so again, you can only cut through a member that has three unknowns at it, right? So I had to make two steps here: cut through, find the force, and then do a joint analysis to find the force in the member that I'm actually interested in finding.